A and B are blocks with weights 44 newtons and 22 newtons respectively, right? So obviously this one is 44 newtons, right? And this one is 22 newtons, okay? So mass of A, right? Mass of A is equal to FGA over G, right? And that is 44 newtons over 9.8 meters per second squared. It's good to find the mass, I think, right? And if you do that correctly, I think you get something like 4.49 kilograms for mass A. And then for mass B, similarly, if you were to do, right, FGB over G, you'll get 22 over 9.8, and I think you got 2.24 kilograms. Okay. All right. A, determine the minimum weight of the block C that must be placed on top of block A to keep it from sliding if mu sub s between A and the table is 0.2. So mu sub s is equal to 0.20. Okay. Now here, the weight of this, okay, is going to be, well, we're going to have basically FGA, and we will have FGC, and the normal force will obviously be this, right? It'll be combination of A and C together, the weight of that, right? So F normal is equal to, right, FA plus FGA plus FGC, right? All right, so let's think about the tension here. So for block B, we're going to have FGB down, and we're going to have tension going up, okay? That tension is the exact same tension going this way, okay? So, if this B is not moving, this tension is pretty obvious that is caused by this weight of the block B, right? So if I were to take a look at sum of all forces for B is equal to MBA. MBA. All right. And then sum of all forces for block B is equal to, I mean, it doesn't really matter because which one is positive or negative, but because my acceleration is going to be 0, right? So MBA is equal to tension minus FGB, right? Same thing. So my acceleration is 0 because it's not moving. So tension minus FGB. So my tension is equal to FGB, which is 22 newtons. Well, this tension is this tension. They're same tensions. Okay? So, if I were to take a look at sum of all forces for A, I guess it's A plus C really, because C is on top of it, and they're going to act as like 1. All right? that is equal to MA plus MC times A, because they're going to behave as 1. And of course, acceleration again is 0. So sum of all force for A plus C is equal to then, well, we have definitely tension, right? And we have friction, right, going the opposite way of intended motion. Right? So I guess we could say plus friction. So here we have MA plus MC times A is equal to tension minus friction. Okay? So acceleration again is 0. Right? So tension minus friction is equal to 0. And since tension is 22 already, so my F friction, mu times F normal, is equal to tension, which is 22 newtons. So what is my normal force? My normal force is 0.2 times the normal force is FGA, which is 44, plus FC, FGC, which is MC times 9.8, is equal to 22. Right? Hopefully you should be able to finish this thing with what MC is equal to, right? So so they want us to figure out weight. So you have to figure this whole thing out, right? So what is 22 divided by 0.2 minus 44? Right? I get 66. So MCG is equal to 66 newtons. That is FGC. So I guess if you want to figure out the mass, might as well just do that now. So it is 6.7, just in case if you want to. All right then. What about part B? Part B asks, block C is suddenly lifted from A. All right. Now we have a coupled system that is actually going to accelerate. Okay. So for part B, I have block A, and then I have block B, block B has FGB going this way, which is 22 newtons, right? And then I have tension, okay, tension going this way, and I have tension going this way, and then I have friction going this way, and then I have FGA and the normal force, like so, right? So if you were to look at this whole thing, right, you could calculate the acceleration of this whole thing. So sum of all forces for the whole system is equal to, right, ma, right, plus mb times a, right? And then sum of all forces in the x direction is equal to, well, I guess I could say I got FGB plus tension plus tension plus F friction, right? So here I have MA plus MBA is equal to, this is positive, first tension is negative, second tension is positive, and my friction is negative. This friction is going to be different because now the C is off, right? All right, so these will go, right? We already know what the masses are, so we have 4.49 plus 2.24 times A is equal to, this FGB is 22 minus friction. But what is my friction? My friction is mu sub k is 0.15 times the F normal. Now F normal is just the F normal of C, which is just FGA, right? Which is 44. Okay. So my acceleration, if you calculate it, is equal to, right, 22 minus, what's this, 6.6, and then divide that by this, right, 6.73, then you get something like 2.3 meters per second squared. All right. Any questions? All right. Let's take a look at the next problem. Okay. So here, 3.5 kilogram block is pushed along a horizontal floor by a force of 15 newtons, right? So here we have 15 newtons. That makes an angle of theta, which is 40 degrees with the horizontal. Now it looks like it's negative 40 degrees because it's below the horizontal. Okay, so this 15 most likely going to have to be broken up into its components. All right, so I guess if we want to do that here, we could do it right here. So here's my 15 newtons. This is 40. So I could figure out my Fx and Fy. Now obviously Fy has to be negative because it is below the horizontal. Okay, so I'm going to just put the negative down. But if you want to, you can say F sine of theta which is 15 times sine of negative 40 degrees, okay? So if you do that, you should get negative 9.64 newtons. And for Fx, that's 15 cosine of negative 40, and that comes out to 11.5 newtons, okay? Now we have to think about the normal force. So F normal, maybe I should make it bigger, but let's make it bigger. Too late. And then we have Fg, okay? And most likely my F normal is going to be a lot bigger than that. So, all right. So Fg, now Fg is 3.5 kilogram block, so obviously that's going to be bigger than 15. So my scale's all off. Sorry. All right. So Fg is equal to mg, which is 3.5 times 9.8. And that should come out to 34.3 newtons. Okay? And we have friction, of course. We have friction going this way. Okay? All right. So let's take a look at the y direction first. So if we were to take a look at sum of all forces in y direction, that is equal to m ay, and then you know ay is 0, right? Sum of all forces in the y direction, I have three forces, right? 1, 2, 3. I'm going to consider the direction up positive, okay? So I have F normal, right, plus Fg plus Fy. So 0 is equal to F normal positive, Fg negative, Fy negative. So my F normal is equal to Fg plus Fy, which is 34.3 plus 9.64. I already gave direction here, I know. So don't put the negative back into this negative so that it becomes positive, okay? So here, I already gave direction, so I'm giving direction again, so don't give that direction twice, is what I'm trying to say. All right, so this, all right, so my F normal comes out to, I believe, 43.94 newtons. So that's good to know. Okay. So I can calculate my friction now. My friction is equal to mu times the F normal, which is 0.25 times F normal of 43.94. So my frictional force is equal to, looks like 11 newtons. Now let's take a look at all the forces in the x. So sum of all forces in the x direction is equal to max, and sum of all forces in the x direction is equal to, it looks like I have two forces. I have fx plus friction, right? So max is equal to fax, I'm going to keep that positive, fx positive minus friction. So the mass, which is 3.5 times A, is equal to Fx, 11.5 minus 11. So my acceleration in the x direction is equal to, looks like 0.5 over 3.5, which is 0.14 meters per second squared. All right. So this is B, and this is A. All right. Any questions? All right. Moving on. So here I have block B, and this figure to the right weighs 711 newtons. The coefficient of static friction between block B and the horizontal surface is 0.25. So mu sub s is equal to 0.25. And the weight of the block, so block B, so FGB is equal to 711. Right? Now, what that makes my F normal for B is 711. All right. What's the maximum weight of the block A for which system will be stable? Well, the tension here is what's really pulling this block B, but that has to be countered by the frictional force going in the opposite direction. Right? And the tensions, right, are going to be pretty much, right, tension A, tension B, tension C, going to have to be all calculated out, and there will be different tensions. Okay, so here I have TA, and then I have TB, and it should get tested for TB, right? And then TC, these tensions are going to be exactly the same going the opposite way from this knot. Okay? So if I were to look at just this separately, so this is TB, this is TC, and this is TA. And if I were to isolate this by itself, and isolate this by itself, this is of course FGA, which is MAG. All right. This tension here, TC, will have X and Y component. So here you could say TCX and TCY. And this angle here is 30 degrees. All right. And let's take a look at force diagram for this. We have TB going to the right. Obviously, we have FG, B, which is 711. And then we have F normal B, which is 711. And we have friction. So we know friction is equal to mu times F normal. All right. So what is friction? We could probably figure that out. So friction is equal to mu, which is 0.25, times F normal, which is 711. So the frictional force is equal to that much. Okay? Therefore, if I look at just this isolated free body diagram of block B, right? So sum of all force for the block B is equal to mba. You know acceleration is 0. And then sum of all force for the block B is equal to, right, tension B plus friction. So 0 is equal to tension B minus friction. So tension B is equal to 177.75 newtons. Okay? Then if we take a look at the block A, right? Well, the block A is going to have tension A, and tension A is same as, so sum of all force for A is equal to, okay, let's see, MAA, and then sum of all force for A is equal to, it doesn't really matter, right, which one's positive or negative, TA plus FGA, right? So 0 is equal to TA minus FGA. So TA is equal to MGA, okay? Or MAG, I should say, sorry. MAG, all right? But we don't know what the mass is, huh? We don't know what the mass is. But we can say, by looking at this TB is also equal to TCX. Why? Because the X component of my tension here, so TB and TCX has to be equal to each other. Okay? So if that's true, then my TCX is equal to TB, which is equal to 177.75 newtons. Therefore, my TC times cosine of 30 is equal to my TCX. So my TC is equal to 177.75 newtons. Divide that by cosine of 30. Therefore, my TC is equal to 205.25 newtons. Therefore, TCY is equal to TC sine of 30 degrees. So my TCY is equal to 205.25 times sine of 30, which is half of that. So my TCY is equal to, I guess, 102.625, whatever, right? Newtons. So since my TCY is equal to 102.6, here TA and my TCY should cancel each other out. Okay? So my TCY is equal to TA, which is equal to 102.6 newtons. Well, now that I know that, I can substitute that in there, say MAG now is equal to 102.6 newtons. So that is the weight of the block. Okay? Any questions so far? All right, moving on. All right, body B in figure to the right weighs 102 newtons. Okay, so FGB is 102 newtons. You know you're going to have, right, horizontal and vertical components of this, right, FGY and of course FGX. And this is the right angle here. So this angle here is 40 degrees. Okay. And body A weighs 32 newtons. So this is okay. So it might be a good idea to find the masses of these. Okay. So what is the mass of A? Mass of A is 102 over 9.8, and that should come out to 10.4 kilograms. And I guess you could figure out the mass B as well. Mass B is equal to 32 over 9.8, which should come out to 3.27 kilograms. So these are good to know. Okay. All right. The coefficient of friction between B and the incline, mu sub S is 0.56 and mu sub K is 0.25. So there are two frictions involved. So here, let's think about the friction of mu static friction is equal to mu sub S times F normal, right? But what is F normal? Well, F normal is FGY basically, right? F normal B is equal to just mg cosine of theta, which is 102 times cosine of 40 degrees. So what is the F normal? Let's see. 102 cosine of 40, and I get, well, Whoa, something's wrong. Ah, I see. Degree. Alright, so yeah, okay, so let's try again. 102 cosine of 40. Better be positive. Yeah, there you go. 78, right? It looks like 78.1 newtons. Right? So here, we could calculate the mu sub s times F normal, which is 0.56 times 78.1, and that comes out to, I guess, 43.76 newtons. All right. All right. Then what about the kinetic friction? Now, now this is the one that slides, right? So that's mu sub k times F normal, and that is 0.25 times 78.1. So I get 19.53, right? All right. So that's good to know. So let's take a look. A, find the acceleration of the system if A, B is initially at rest. If B is initially at rest, I have to find out which way this thing's going to go, right? Is the friction big enough to hold this thing from sliding? Well, what is this FGX pulling down this way? Let's figure that out first, right? That is 102 times sine of 40 degrees, right? So my FGX is equal to, I get 65.6 newtons. Okay? So obviously, this will slide this way, but because of friction now, it's going to act in the opposite direction. Because if there were no friction, this is definitely bigger than this, so it will slide this way. So its tendency of intended motion is going to be down the incline for B. Therefore, my friction has to act up, right, in this direction. Okay? So if it's at rest, okay, right, um, this frictional force does not have to be 43.76, right? Because the tension has to be 32, and then if I add this, it's going to be bigger than that, and that's not going to make it try to go that way because of friction. All right, friction is a reactive force, so it's only going to require whatever it is necessary to just keep it stable. So if that is true, okay, let's find out how much friction is required to keep it stable. Okay, so here we know sum of all force is equal to MA, which is equal to 0 in our case, right? Because it's stable. So sum of all force is equal to, here I have FG X plus friction, right, plus friction. And then I have tension minus tension, right, minus FGA, okay? So, sorry, maybe I should just make it all pluses for now. Sorry, skipping too far ahead. I'm in a rush. So 0 is equal to now. Here, let's give directions. I'm going to consider the direction of intended motion to be positive. So FGX minus friction, right, minus tension, plus tension, minus FGA. So obviously these will cancel out, right? So let's solve for friction. How much friction is required to keep it stable then? So my friction is equal to then FGX, which is 65.6, minus 32. So the friction that's required to keep it from moving is 33.6 newtons. Well, I definitely have that because my calculated maximum value of static friction is 43. So since F friction static max has maximum of 43.76 newtons, right? It only requires 33.6 newtons, therefore it will stay. Okay? It will stay. It does not move. Okay? All right, what about part B? If B is initially moving up the incline, then what happens? If it's initially moving up the incline, the frictional force obviously has to act in the opposite direction of the motion. But because the friction is acting down and Fg is acting down, it's going to start to slow down. Right? It's going to start to slow down. So somebody must have given a push, like it's given a shove to initiate that motion. Okay? So what is the acceleration? It's going to slow down, so my acceleration is going to have to be negative. Well, let's find out what it is. Right? So for part B, because the direction of motion is up now, so since this direction is positive is up, okay, my Fg is negative, and my friction will go in the opposite direction of motion, so my friction is down the incline, and my Fgx is still going to be down, all right? So that is what's going to happen. So then we have tension, and FGA, and FGA is going to be positive this time, all right? So again, sum of all forces is equal to ma, but this time my acceleration is not going to go to 0. And then sum of all forces, here I have FGA, right, minus tension. Oh, I'm going to just put that all in positives for now. Okay, so plus FGX plus friction. Okay. However, when I set them up, ma, right, this m is the mass of the whole system, basically. So mass total times A is equal to FGA is positive minus tension plus tension. FGX is negative minus friction. Okay? So, what is the mass total? Mass total happens to be 13.67, right? So I'm adding the masses up, times A is equal to FGA, 32. These two tensions will cancel out, minus 65.6, minus, now this time, since it's sliding, this has to be kinetic friction, right? Because it is sliding. So we have to use this 19.53 now, right? All right, so now we just have to solve for A. So my acceleration is equal to, so 32 minus 65.6 minus 19.53, divide that by, so I get negative 53.13 divided by 13.67. All right, and I get negative 3.8889 meters per second squared. Okay. All right. Now, what if B was moving down the incline? So for part C, now we still have FGX going down. That's going to be the positive direction now, right? So this direction is positive, right? But now our friction is going to act up the incline, and that friction again is the kinetic friction. So that's the negative, all right? So what changes? Just directions change. All this still remained the same, okay? So this time, a lot of things, all the directions change. So here we go. So sum of all forces is equal to MA. Now this is total mass, right? M total. And sum of all forces equal to, here we go. Ready? I have FGX plus friction, kinetic friction that is, plus tension minus plus tension, sorry, and then plus FGA. So when I set these equal to each other, right, my M total A, right, is equal to FGX positive minus friction kinetic minus tension plus tension minus FGA. So my M total, which is 13.67, why did I use that color? Times A is equal to FGX, which is 65.6, minus friction kinetic, which is 19.53. Again, these two will cancel out, minus 32. So what is that? So I have 65.6 minus 19.53 minus 32, and I get 14.07. Divide that by 13.67. and I get positive 1.03 meters per second squared. Phew, that was a good problem. Okay. Any questions? All right. Good. Um. Yeah, I don't like this negative sign in front of that. That should be positive. Where going down direction here is positive direction. All right. Block on blocks. Okay. Block on blocks. So for the top block, this is non-inertial frame of reference, right? It is the friction between the top block and the bottom block is actually keeping this block from sliding off the bottom block, right? All right. So let's read the problem first. A 4 kilogram block is put on top of a 5 kilogram block. To cause the top block to slip on the bottom one, which held fixed, a horizontal force of at least 12 newtons must be applied to the top block. Okay? So if I want to move this thing, I have to apply at least 12 newtons of force, right? Newtons of force to be applied to the top block to get that thing moving. The assembly of blocks is now placed on a horizontal frictionless table. So this is frictionless, but this still has friction. Find the magnitude of the maximum horizontal force that can be applied to the lower block so that the blocks will move together as one. So let's understand that there's friction here, right? There's friction between these two. And the friction, right, on the top block, right, by the bottom block, right, is going to be going in this direction, okay? So the friction on 4 by 5, right? And then there's going to be friction going the opposite direction for the bottom block. The friction of on 5 by 4. This is the action-reaction pair, okay? The magnitude is exactly the same, okay? So the friction of maximum friction, that is, of static friction, between the top block and the bottom block was told to be 12 newtons, okay? So this 12 newtons is what's keeping this top block moving forward with the bottom block, okay? So this friction right here is actually pulling, okay? Is pulling the 4 kilogram block, forward with 5 kilogram block. Okay? So let's find out what the acceleration of the whole system is. Well, if we could find the acceleration of the top block, that acceleration is going to be exactly the same acceleration of the whole system, including the 5 kilogram block and 4 kilogram block together. So the acceleration of this should be acceleration of the whole system. All right. So let's find the acceleration of top block. Okay. Which is the acceleration of the whole system, basically. So here, okay, we have 4 kilogram of force, 4 kilogram of mass being applied by force of 12 newtons. So F equals ma. So F equals just force friction, and ma is equal to friction, and that is 12 times 4 times a. So my acceleration is 3 meters per second square. All right. So that acceleration is acceleration of the whole system. Now I have four plus 5. So the total mass, so F, I guess, pull, right? F pull is now what's we have to figure out. Since they move together as one, right? The sum of all forces equal to, right? 4 plus 5a, right? And sum of all force is equal to just F pull, because there's no friction at the bottom. So 4 plus 5a is equal to F pull. Now we know the acceleration, so 9 times 3 is equal to F pull. Oops, F pull. So F pull is 27 newtons. So this is actually part B, and this is part A. All right. Any questions? All right, more block on blocks. So we have 40 kilogram slab, right, rest on a frictionless table or floor, and then we have 10 kilogram block rest on top of the slab. The coefficient of static friction between the block and the slab happens to be 0.6. Okay, so we have mu sub s is equal to 0.6. And there's definitely friction here. And the kinetic friction between the block and the slab, so mu sub k is equal to 0.4. The 10 kilogram block is pulled by horizontal force magnitude of 100 newtons. What is the resulting acceleration of the magnitude? Well, I want to know what's the maximum friction for the static and kinetic. So if I pull 100 newtons of force, and if the static friction happens to be less than 100, then it's going to start to slide. That means we can't use that force anymore. We have to use kinetic. However, if the force static friction is bigger than 100, then it's going to stay at 100 and it's not going to slide and it's going to make both of them move together. So I think we should figure out what's going on with far as which friction we're going to have to use. So let's calculate the static friction first, which is mu sub s times F normal. So mu sub s, of course, is equal to 0.6. F normal is 10 times 9.8, which is 98, right? So what is that, John? That is 58.8 newtons. So obviously that's not going to be big enough to hold this thing steady, because if you're applying 100 newtons of force horizontally, 58.8 newtons is not going to be enough to keep it steady, right? So it's going to most likely start to slide. This top block is going to slide on top of the bottom slab. So let's calculate the frictional force for the kinetic friction, which is 0.4 times 98, and that comes out to 39.2 newtons. Okay? So we must use the kinetic friction instead of static friction because 100 newtons is too big to keep it as static. All right? All right. So what's going on? Well, if we're going to consider this direction to be positive, because this is the direction of motion, okay, I'm going to keep that direction positive. So friction obviously now is going to act in the opposite direction of motion. So this is a friction here, friction, and that has to be the kinetic friction. Okay, so if I were to redraw this, I'm going to have obviously Fg going down, right? Fg, and then F normal, and then I have F pull, which is 100 newtons, and I have frictional force kinetic, which is 39.2 newtons. All right. So we're going to, like I said, consider this direction to be positive. Okay. Just like to make the direction of motion positive. So here, I have sum of all forces is equal to ma, right? So what would this acceleration be, right? What would the acceleration be? So sum of all forces, again, is just force pull plus F friction, right? Kinetic. So ma is equal to F pull positive minus F friction kinetic. So M, 10 kilograms times A is equal to 100 minus 39.2. So if you work out the acceleration of the top block should come out to 6.08 meters per second squared. Okay. Now let's take a look at the bottom slab. Okay. The bottom slab is going to be moving not at same acceleration. This is going to slide on top of that bottom slab at this acceleration. But the bottom slab, it's going to get pulled by the friction, which is this kinetic friction value at the top. So what's pulling the bottom sled or bottom slab is the kinetic friction caused by the top block and the bottom block. Again, I'm going to consider this direction to be the positive direction, right? And since there's no friction between the floor and the slab, there's no other horizontal force except for this force only. This is the only force that's making this bottom slab accelerate that way. All right? So again, we have F normal going this way, right? And then we have FG going down this way. But that's about it. But this FG must include the top block as well, right? So this is 10 plus 40 times 9.8. And of course, this is just same as FG. So here, this is 50 times 9.8, right? Is that what, 490? Right? And then this is 490. But that doesn't really matter because this does not have friction for the bottom. So you don't have to worry about this normal force at all. So if I were to look at sum of all forces in the x direction is equal to ma, and don't forget, this friction is only accelerating this mass, so this is only 40 kilograms. All right. So here, I only have frictional force, kinetic. So ma is equal to F friction K. So this mass is 40 kilograms because this friction is only making this move, right? And this is the 39.2 newtons. So my acceleration for the bottom slab is 0.98 meters per second squared. All right. All right. All right, let's take a look at the next one. We have force pushing a small block M against the large block capital M. Right? What's causing this small block M from falling straight down? Well, we know you're going to have FG going straight down this way, but the friction between the two blocks is keeping that up, right? So the push, F push, which is this, right? And there's going to be normal force caused by big M to the small m. So F normal, right, on small m by big M. There's going to be normal force going this way, F normal on big M by small m. This normal force right here is going to make this big M accelerate in that direction. And that acceleration is same acceleration as this small m. Okay? So if I were to take a look at this friction caused, so friction on small m by big M is going to cause friction here in the opposite direction, which is same value as this, on big M by small m. Then I have Fg of big M, right? And I have F normal of big M, okay? So this is action-reaction pair right here. This is action-reaction pair, okay? So let's think about what happens in the y direction for this, for the small m, okay? So sum of all forces is equal to ma, and sum of all forces in y is equal to, well, it looks like I have Fg plus friction, but Ay is 0, obviously, right? Ay is 0. So here, I have 0 is equal to, I'll keep the Fg positive if you want, right? It doesn't really matter, minus friction. So my friction, right? My friction here is equal to Fg, which is mg. However, my friction is mu times F normal. This F normal is that F normal right there. Okay? So mu sub S, which is 0.38 times F normal, is equal to mg, which is 16 times 9.8. So what is my F normal? My F normal is, then, I guess it comes out to 412.63 newtons. So once I get that F normal, let's take a look at the direction for the motion for this, okay? So x direction for my big M, right? So sum of all forces is equal to ma, and sum of all forces is equal to, I just have basically F push, because these will cancel out basically, right? These will cancel out, right? So F push, right? F push, I mean, if you want to, you can actually do the whole thing, right? Actually, you know what? Let's do this. You know what? Let's just do it, just this by itself instead of looking at the whole thing. I mean, that's one way of doing it. Let's just do the F normal first instead. Let's just do it that way, so I don't want to confuse you. Let's just do this, just big M first. Then, if you were to do it that way, you're going to get MA is equal to F normal, right? We already know what the F normal is. So 88A is equal to 412.63, okay? And then acceleration should come out to 4.69 meters per second squared. Now that you know the acceleration of this big block, that acceleration is acceleration for the whole system. Okay? Therefore, if I were to look at this, sum of all forces for the whole system, right? And that's just F push, right? So F push is equal to 16 plus 88 times 4.69 is F push. So F push is equal to 488 newtons. All right. Thank you for sticking with me. And we'll stop there. Have a wonderful weekend, everybody.